We're going to look at how do you manipulate k-values in the screencast. So equilibrium constants are specific to the balanced equation. So if you're changing the coefficients of the balanced equation, your k-value is going to change as well. So if we look at the normal way we would balance the formation of ammonia equation, it gives a k-value of 3.5 times 10 to the 8th. So remember that this is highly favored to be the product of NH3 rather than the free elements. If I balance it using fractions, I'm now going to change my k-value. So in this one, the k-value is the NH3 concentration squared and the N2 and the H2 cubed. Okay, again, this is assuming it's a Kc. If we do this one, we're going to get a k-value of NH3, N2 to the 1/2, and H2 to the 3/2. So you'll see that from here to here, it's half of all your powers. And a power of 1/2 is the same as square root. So if I take the square root of 3.5 times 10 to the 8th, okay, that's the same as taking 3.5 times 10 to the 8th to the 1/2 power. And you can do your square root key, or you can use your power key to do 0.5. Either way, you'll get 1.9 times 10 to the 4th as your answer to that. Okay. All right, these constants are also specific to the direction of the reaction. So you saw this with Hess's law. If you change the direction of heat, it changes the sign, the same thing. A change happens here, but here the change is the reciprocal. So because you're basically, if you go up to this concept here, you're going to flip all of this. So that's why it's the reciprocal. So if we go back to this equation, this time we're going to have N2 and H2 cubed over NH3 squared would be your k-value. So since it's inverse, we're going to take 1 over 3.5 times 10 to the 8th. And that's going to give me 2.9 times 10 to the negative 9th. So again, notice that since this is negative now, this is reactant favored. So again, it would make sense that you reverse it. The opposite is going to be true. If it was highly favored in one direction before, it's going to be highly favored in the other. All right, and then the next part, if we have multiple equations. So in Hess's law, we add in equilibrium, we multiply. So sometimes you have to do this if you can't find the equilibrium of all of them. So I'm going to have the concentration of F, and that's elemental F, concentration of NO2F over NO2 and F2. So I'm just taking this equation and going here. Now, I'm going to scoot this over so I have a little more room. So this one is going to be the concentration of NO2F over F times NO2 okay. And then here, this is like a mechanism. You'll see that those cancel. And I really have two of these. So this plus this is giving me 2. And this plus this is giving me 2. So my equilibrium for this third one is NO2F over NO2 squared times F2. And again, if you would multiply these two together, so this is your 2, and I'm going to put 1 over here. You'll see that it does work out. So this cancels. So miss the squared on that one. You'll have NO2F squared. So you have this times this, and you'll have NO2 squared and F2. So you really multiply the equilibrium constants. Okay, next set has KPs. So we want the reaction of H plus Br yields HBr. So again, if I look at this mechanism here, I need to cancel my H2s. So you can do quite a few things here to do this. There's 2 methods to do this. So if I reverse my equation here, so I need this H as a reactant, so I'm going to flip this. So this is going to be 2Hg yields H2. So I'm going to do 1 over 4.8 because I'm doing the reciprocal. Okay, you can see how high this number is. The atomic form of hydrogen is not favored at all. Okay, it wants to be in that diatomic form. And then I'm going to do the same thing with the BRs. I'm going to reverse that equation. Oops. Get ahead of myself here. I can think faster than I'm writing. Br2 gas. So I'm going to do 1 over 2.2 times 10 to the negative 15th, and that's going to be 4.5 times 10 to the 14th. Okay. And then I have my H2 gas plus Br2 gas yields 2 HBr. So my H2s are going to cancel, and my Br2s are going to cancel. So I have 7.9 times 10 to the 11th. So this is really going to leave me with 2Hg plus 2Brg yields 2 HBr. So it looks a lot like Hess's law. So when I multiply all of my KPs together, so KP of 7.9 times 10 to the 11th times 2.1 times 10 to the 40th, and 4.5 times 10 to the 14th, that's going to give me a combined KP of 7.5 times 10 to the 66. Now the only problem I have is that these are 1s. So again, if I'm dividing both of these by 2 to get this H plus Br, okay, I'm really taking this whole thing times a half. So dividing by 2 is the same as a half. So I'm either going to take the square root of this number, or again, if you don't like the idea of square root, square root is just taking it to a power of 1/2. Again, my calculator has the y to the x key. Yours may have that caret button, so that power key. And when you get that, you get 2.7 times 10 to the 33 as your combined Kp of this reaction. Okay. Now, there is another way to do this. So if you want to just do the fractions directly, you could have done the fractions. So I could take each of these times 1/2. Either way, you're manipulating, so it's just which method you like to do. So that would give me 1/2 H2 plus 1/2 Br2 and remember, I'm taking 7.9 times 10 to the negative 11th to the 1/2 or square root, and that's going to give me 8.9 times 10 to the 5th. And then I have to take 1/2 of this and reverse it. So I think this is more steps. I think the first method I did is easier, but it's not wrong to do it this way. Oops, this would just give me H, sorry. So that would give me H yields 1/2 H2. So reversing it is the reciprocal, so 1 over 4.8 times 10 to the negative 41st times 1/2 is going to be 1.4 times 10 to the 20th. And then the same thing, I'm going to take 1/2 and reverse this one. So I think it's simpler to just take the 1/2 at the end, but either method is fine. So this is going to be Br yields 1/2 Br2, and then 1 over 2.2 times 10 to the negative 15th. Square root, or 1/2, is 2.1 times 10 to the 7th. And then you would multiply this times this, and you should get the same Kp of 2.7 times 10 to the 33rd. So again, that part's the same as far as manipulating. The key thing is understanding these two concepts is if you're combining K values, they're multiplied, and if you are changing the direction, you're using the reciprocal. So those are the two keys for manipulating equilibrium constants.